for the protection of industrial generators and motors. Whenever there is a fault, the Hall effect sensor senses the abnormal condition and sends a signal to the comparator. The comparator compares it with the reference voltage and it senses whether it's an over voltage, under voltage, and then sends a signal to the IC. And if the signal is processed and then transmitted to the transmitting antenna, and then the signal is received by the receiver circuit. The receiver circuit receives it and the signal is passed on to the IC and the signal is processed and then an output signal is generated. This output is connected to the relays. For example, when there is a fault at M1, the M1 is connected to D1. So when there is a fault in M1, D1 will be the comparator will send a signal to D1 and then the signal will be generated and transmitted and D8 will be triggered. In the similar way, G2, G1 and M2, whenever there will be fault, the respective signal will be, the IC will receive the signal and the respective relays will be triggered. The practical implementation of the whole circuit can be seen here.
Here we have a practical implementation of the transmitting end. The switches represent the generators and motors G2, G1, M2 and M1 respectively. This is the transmitting circuit along with the antenna. We are using a biasing voltage of 5 volts. Now we move on to the receiving end. At the receiving end we have the receiver circuit. The red LED represents the reception of the signal and the green LEDs represent the relay which will be tripped. So for example, if we see a fault at generator 2 G2, then the respective relay is switched off for G1, M2 and M1 respectively. One of the biggest advantages of this circuit is that it has a wide range of around 150 meters. Therefore, if we take the cost effectiveness and this wide range into consideration, then this is a very good solution for industrial protection.